This time we're going to solve for example 2, which is on equation of planes. So the first example here, example 2a, is to find an equation of the plane which is supposed to be containing the points 2, 0, 5 and 0 to negative 1 and perpendicular to the plane x plus 3y minus z minus 7 equal to 0. So let's take a look at the following plane. So if this is a plane, so suppose this is your plane that contains, this your plane that contains 205, the point 205, and at the same time it also contains the point 0 to negative 1. So it contains this p sub 1 and p sub 2. This plane should be perpendicular to this plane. So you consider the plane perpendicular to this. But this is your plane. It contains, ito na plane na. This plane is the plane. It should be perpendicular to the plane with equation 3x x plus 3y minus z minus 7 equal to 0. What does it mean? We know that a plane, for an equation of a plane, we need to have a point, p sub 0, and also a vector, which is perpendicular to the plane. So those are the requirements. And the equation would be, the equation of the plane is a times x minus x sub 0 plus b times y minus y sub 0 plus c times z minus c sub 0 equal to 0, where your p sub 0, contains, you have your x sub 0, y sub 0, z sub 0, and this vector, which is supposed to be perpendicular, we call that the normal vector, has direction numbers a, b, and c. So that's the equation of the plane that we're looking for. So in this case, we take a look. We already have a plane which contains this, so we may use one of the points for the plane, but because the given plane is perpendicular, this perpendicular plane we know has a normal vector. It contains a normal vector n1 with direction numbers. You have ax plus 3y minus cz, minus 7 equal to 0. So the direction numbers are actually 1, 3, negative 1. And since this direction number n1, 1, negative 3, negative 1, is perpendicular to this given plane, then it should be this plane. This plane has this vector here on this plane is actually parallel. These vectors are parallel. This vector is supposed to be parallel to this plane. So that, what do we need now? We know that we need a vector which is perpendicular. So what we're going to do is to take the cross product between this one and any vector that we can come up with from this plane. And that vector would be the vector p sub 0 or p sub 1. P. You can make use of p sub 0 to p sub 1. If you make use of this as your p sub 0 and this is your p sub 1, which are points on the plane. So p sub 0, p sub 1, that's a vector. Cross product with this 1 with n sub 1. So that should be, this now is a vector which is perpendicular to the required plane. Okay, so with this in mind, we can go on with our solution. That is, we take first our p sub 0, the vector p sub 0, p sub 1, which is equal to, we have p sub 0, p sub 1, we do, this is our p sub 0, this is our p sub 1, then have 0 minus 2, then 2 minus 0 is 2, then 1 minus 5, oops, sorry, the negative 1 minus 5, negative 1 minus 5, minus 5, minus 5. And this vector is parallel to the plane, that is negative 2 to negative 6. And we take n sub 1, which is equal to 1, 3, negative 1, 1. We have there your ax plus by plus cz, oops, cz minus d equal to 0, right? So this is your n sub 1, 1, 3, negative 1. And we take the cross product between this, p sub 0, p sub 1, cross product with n1 equals cross product with p negative 2 to negative 6, cross product with 1, 3, negative 1 should give us ijk. We'll have negative 2 to negative 6, 1, 3, negative 1, which is equal to, we have the determinant of 2, negative 6, 3, negative 1, I, and this is always a minus. It's the determinant of negative 2, negative 6, we have 1, negative 1, j, plus we have this out, we have negative 2, negative 2, 2, 1, 3, and then determinant k, I'm sorry, vector k, so I did k vectors. So that should give us 3 minus 1. Let me just write this as, we have 2 times negative 1 minus negative 6 times 3. We have minus, we have negative 2 times negative 1 minus negative 6 times 1, and then we have negative 2 times 3 minus 2 times 1. Okay, so that should result into negative 2. This is plus, that becomes plus 18. This is negative, the negative of this negative 2, that's plus 2. So I have 2, then this is minus with minus, so that becomes plus 6. And then this is negative 2 times 3, that's negative 6. Also the parenthesis. Negative 6 minus 2. So that means to say the cross product is equal to, it's positive, you have 16, then negative 8, and you have negative 8. So meaning to say, we can write that as, very right, 16, negative 8, negative 8 can now be rewritten as, let's continue the continuation. We know that p sub 0, p sub 1, cross n1 is equal to 16 minus 8 minus 8, which is actually the same as, so we are to solve this time equation. The plane containing the points 2, 0, 5 and 0, 2, negative 1 perpendicular to this plane. What we did earlier was to have the following. Let's see what have we done. Right. So far we have already solved for the vector which is perpendicular to that plane, which is 16, negative 8, negative 8. So the perpendicular vector that we have is, let's see, the vector that is perpendicular now is p sub 0, p sub 1, we call that n, cross n1. We had solved that to be equal to 16, negative 8, negative 8. It's the same as 2 times, we can have 8 here. 8 times 2 minus 1 minus 1. And we are given a point p sub 0, 2, 0, 5. So the equation of the plane now, of the plane is a x minus x sub 0 plus by minus y sub 0 plus c z minus z sub 0. Your a here is, you can have that as 0, 2. X minus x sub 0 is 2 plus b, which is negative 1. Y minus y sub 0. Our sub 0 is 0 plus c, which is negative 1 again. Z minus our z sub 0 is 5. It's supposed to be equal to 0, so it's equal to 0. We have 2x minus 4 minus y minus z, and then you have plus 5 equal to 0, or that can be rewritten as 2x minus y minus z